4x and the dx, so I put the 10 over, make it to du. I rewrite it as 1 over 10 u to the 5th du, and then I take the antiderivative using power. So then I take the 5 to the 6, and then multiply the number 6, so then negative number 16, and I take it to
This is a pretty classic Russo problem. Did you guys have any questions about this one? Or do we feel mostly okay? So how are we doing? Do you want to keep working on some of these, or are there particular ones that anyone would like to talk through as a group? 9? Yeah, okay. Do you want to do 9 down? Or alright, so if you want, you can write. Do you want to write it up and then tell us what you did?
Sure, when you guys prefer.
You can.
What about like you're stuck on one part of one of the questions? Can I write what I have and then just help me out?
Yeah, totally. So do you want to do one until you get to a stuck point or stuff? Yeah. Okay.
Well, you go first.
Alright, I'll
Do this.
Yeah, we can erase this stuff. I think we all feel like good about these problems now, so we can erase these. And actually, yeah, if you want to start writing up, so Dylan, you can use this board, and then Bertha, if you want to come up and you can start writing up, and then we can take turns. Does anyone else want to put up a problem or? I have more chalk too. If you guys need more. Do you guys have any questions while we're writing stuff up? Number 6, okay. So number 6, here's how it's tricky because the -4, right? If the -4 wasn't there, do you have an idea of how you might do it? So what if I told you, so like the 3 is just a constant, and kind of like pull it off to the side, and then you go 1 up top. So if you had inside, it's kind of like 3 times 1 over x. How do you integrate 1 over x? ln. That's good. So then what you can start thinking about is either, did the -4 change anything about how you would be using ln? Or another way is kind of like, well, if I just have an x in the bottom, that's good. And here you're like, I've got an x minus 4, so maybe I could do like a u substitution where I let u be that x minus 4 and kind of see what happens.
So would maybe we have
Yeah, actually that's exactly right. That's exactly right. That's,
that is the answer?
that actually is the answer. Yeah. I know, right? Exactly. It does seem like it's too easy. That's why I put that one on there because actually these sorts of problems you will see a number of times where you will find out that -4, that +2 or whatever, it actually doesn't affect the natural law. Oh, in the absolute value, that's right. And also, if you did a u sub, and you're like, I'd let u be x minus 4. The derivative of x minus 4. Just once. When you have problems like that, it means that you're not changing that, like, there's no shift by a number or anything, so then you just put the x minus 4 back in, and nothing will change. And that's why it really is natural log of x minus 4, where it just doesn't get changed. Yeah. So that one actually is just 3 times x. Oh, okay, awesome. Are you ready to go? You want to tell us about your idea? All right, so Dylan's going to tell us about number 6, because I know this one was kind of tricky.
Number 9.
Number 9.
Oh, number 9. Yep, thank you. Number 9. We were just talking about courses.
So So basically what she told me is, since you can't really find a way to make this, you know, more factored out or simplified in my opinion, I use substitution to figure what are my options basically. And I turned it into, because you want to factor on the top, or simplify the top, so I ended up with u minus 2 over u, and I split that up with u over u and minus 2 over u, which left me with minus 2 over u, replace the u with x plus 2 plus c.
So can you elaborate, because I think the really tricky part that goes into this is you let u be the x plus 2, right? Because that was the denominator and you wanted to replace it. So u is x plus 2. How did you know how to get rid of the x on top?
It's kind of hard to explain, that's why like it just comes to me.
Yeah.
You would have to have everything in U, right?
So yeah, so like you want to turn everything into u's. So you know that u is x plus 2. So what is x in terms of u? And you have it written there, Dylan, right? What is x equal to in terms of u?
Oh,
Like
u minus 2.
Yeah, u minus 2. So this is one of these, this is very tricky. You let u be something. When you did your du, and I guess here you mean 1 dx, technically.
Oh, yeah.
Right, the du. So, oh no, that's good, that was the
Alright.
dx. But I mean in the second line, the du equals 1. The u, of your u substitution. You've got u equals x plus 2. You've written that at the very top.
Where the du at.
I know,
Oh.
sorry. Yes, exactly. So you mean a dx there. Okay. dx. Okay. So you said, I'm letting u be x plus 2. Then when I do my du, it just gives me dx. So I can like swap out my dx straight up for the du. But that leftover x on top, how do I turn it into u's? Well, Dylan just said, well, I have an equation, and it relates u and x. So if I need to know what x is in terms of u, I could just rearrange that equation, and then you swapped in the u minus 2. So do we feel okay with like how he got from the x over x plus 2 to the u minus 2 over u? Okay. So now, then what did you do? You got the u minus 2 over u.
And then I separated them to turn them into just one, like,
Yeah, you broke it up into these two fractions that have like a more simple numerator, u over u cancels, minus 2 over u. So then I guess technically when these the u over u cancels, it's not that it just disappears, what does it actually become? So it actually becomes a 1. So we've got 1 minus 2 over u. And then, and this is the part that gets, especially when you do hard u subs that involve multiple steps, we actually can't forget to actually take the integral. So I think, like you did all this really nice work, but secretly there's an integral sign here, right?
yeah.
So where else is there an integral sign?
Isn't it right here?
Yep, okay, so there's an integral sign right here, and this is the du or whatever. And then there's an integral sign here, and then there's still an integral sign here. So maybe I'll just write this down below to make it more clear. There's still an integral sign here. So actually, before we can put the x's back in, so you were good, you put the x's back in, but you forgot to do the integral. And this is something that we do a lot because there's so many steps that go into u sub that we kind of like put all this stuff in, do some stuff, and then sometimes just put the x's back in and forget to integrate. So I would be careful just in general about like when you're doing these integrals to not drop the integral sign even though you're like, yeah, I know I'm doing integrals, so that you remember to integrate. Okay, so then let's finish it off. So what's the integral of 1? 1x, but instead of x, what is it this time?
Or u.
U, okay, perfect, so it's u, and then how do we do something that's like a 1 over u?
It's 2 u minus 1.
2, so this is a u to the minus 1, that's right, but the integral of that is special, it's not the power rule. L,
Natural.
yeah, natural log, okay. And then what would you do to finish it off, Dylan? Like you you've integrated.
Oh, you just plug in the view.
And then now you would plug in all of your x plus 2 minus 2 natural log of x plus 2. Okay, so how do we feel about this kind of like clever use of? If it doesn't work out evenly, you still can do a nice rearranging to get rid of all of your x's and turn them into u's. Questions about this one? Okay, thanks, Dylan. Okay. Do you want to tell us about how you got started, Maritza?
Sure. So for my view, I kind of rewrote this. So then I put u and I subtract and I divided to the other side. So then after I divide to the what I get. That and I put it
Okay, so now do we feel okay, like all of this has been translated into an integral that just has u's, and it looks a lot simpler than the one we started with. Do we feel comfortable with the steps so far? Okay, so now let's help Maritza out. We have this integral, and what kind of integration rule do you think you want to be using, Maritza? Like, why did you change the square root symbol into a 1/2? Because it's easier, because you see that it's a power function. So like, we probably want to do the power rule, but we can only do it if that u is like up top. Yes. Great. So then how do you integrate that?
Can you flip it?
So you can't, so I think you've already flipped it. So what do we do to the power when we're doing the integral? So like when you do the derivative, we bring it down and we decrease it by 1. What do we do to the power when we're integrating? I know it's like harder and scarier, but you're at the chalkboard. So what do we want to do to the power? We want to add 1. So what happens when you add 1 to the 1/2? We get a positive 1/2. Okay, good. So you got a positive 1/2. And so actually, yes, we don't actually need this, but then you would divide by a 1/2. Right? You would get like, kind of like when you do the, I mean, I think with fractions it gets more confusing, but here's an easier one. What happens if I had like x cubed integral? How does this work? Excellent. Okay, so you just added 1 and divided by that. So you just added 1 to the power, and you would divide by that power, and the power is 1/2. So you actually would have a 1/2 at the bottom. Okay. So either, at this point, you can, you're like, I can just cancel those. So you just have a u to the 1/2. Awesome. And what do you have to do to finish off the problem? Plug in the u. So what are you going to get? Okay, so this is the indefinite, or just the antiderivative answer. How do we feel about this antiderivative? Just for now. So what are you thinking you want to do? So you're thinking that you want to like somehow break this up?
Yeah.
Okay, I agree. These problems, you always think you want to break them up, but you actually cannot break up square roots. And what's so tricky is that the reason you wanna do this here is because you see that these are squares. And you're like, well, square root of x squared is x, and square root of 4 is 2, and I want to do that. And I'm just gonna say right now, this is going to be like one of the things that you are going to wanna do like every freaking day in Calc 2 is break up a square root, and you cannot break up a square root. If it helps you to think like, no, this is bad, like bad news. If you plugged in some numbers, I don't know, like if you said, okay, what do you get when x is 0? Just for fun. Yeah, okay, so you have square root of 4, which is 2. Okay. Oh, that's a bad example. I'm sorry, you guys. Okay, let's do x equals 1. I picked the easiest one because I wanted to make it nice, but alright. So when x is 1, what do you get? Yeah, so you have a square root of 5 in here. Now let's say we really wanted to break this up, and so we did. And we were like, hey look, that's just x plus 2. And we plugged in x equals 1. What do we get? Is square root of 5 the same as 3? Sadly, it's not. So what I'm saying here is that these are not equal. And it's really hard because you're going to see a lot of problems that have this exact form in them. And you're going to get stuck, and you're going to go, I'm stuck, what can I do? And you're going to do this simple manipulation. No, never. Don't ever do it. Okay, so really, this is kind of the best answer we could get for the antiderivative. What do we still need to do, really, to finish this problem out? Yeah, so this problem, like, it really had these bounds. And so technically, like, what we've done is we've done this. This looks good. And then we would just do what Angel did, where he said, well, what bound do you plug in first? So let me just rewrite this. And say that we know that this is going to be square root of x squared plus 4. And we plug in the top bound first. And then what do? Subtract what? The one with the 1 plugged in. And so, great, cool, whatever, this is an answer. Or I guess we could say, hey, it is square root of 13 minus square root of 5, and whatever, that's kind of the best we can do. Yeah. Equals answer, that's right. Okay, so that is one way to handle this problem. Any questions about this one in particular? Would we like to take a break? How are we doing? Do you guys want to take a 10-minute break? No one cares, it's like whatever.
So it's whatever.
Okay. I think, do we all feel like we can get up and use the restroom whenever we want, so it's okay. There's no, I'm not a drill sergeant. Okay. Then how about, I wanted to say something else about U substitution problems that have bounds. So this is one totally valid way of coming up with the answer. You do your U substitution, you do the whole integral, you put all your x's back in, and then you use your original bounds. When you guys go forward into Calc 2, there will be some problems that do substitutions. They get really complicated and long, and actually the step of changing everything back to the x's and then putting in the numbers becomes very tedious. So there's actually another way that you can do U substitution problems with bounds. Have we seen this idea of changing the bounds before, or does this kind of, maybe we've seen it? how about I will go through this problem with the bounds changing method just to give you an alternative that you could use that ends up being nice for some problems. Okay, so this alternative method, I guess I would just say it's the method where you change the bounds. So our original problem was this integral from 1 to 3 of x over square root of x squared plus 4 dx. And Maritza has already given us the way that we do the substitution. So we already know how to turn everything into u's. And she did that for us, and she said, hey, this is going to be the same as 1 over 2 u to the 1/2 du, where I have this integral. Now, I cannot actually say at this point that this integral is equal to this one. This one is going to give me a number, right? I finished out the problem and we even know what it should be. Written this way, this is actually not a number, right? It would give us a function because we don't have bounds. But unfortunately, I also can't say like, hey, these are equal. Because in fact, if I finish this and plug these bounds in for u, I won't get the right answer at all. I know I have to turn it back into x's before I can plug in the 1 and the 3. But we could be smart and say, look, here's an integral that's all in terms of x, right? And so really what that means is these bounds are in terms of x. So when I turn my whole integral into in terms of u, these bounds really should be u equals something, right? It shouldn't be x equals something, it should be u equals something. But luckily, we know what u equals in this problem. What did Maritza say u should equal in this problem? X squared plus 4, right? So cool, this was all the u sub stuff. So if u equals x squared plus 4, and I need to change my bounds to be in terms of u, how can I do that? When x equals 1, what is that really telling me u is? In other words, how do I take x information and turn it into u information? What's the formula that tells me how to do that? In this problem, what formula or equation relates x and u? This one, right? This is our, think about this as coding and decoding, right? This is the code that we use to change x's into u's, or u's back into x's. So when x is 1, what is u going to equal? It's going to be 5, because it's going to be x squared, which is 1 squared plus 4, and this is 5. So how about when x is 3, what will u be? It will be 13, because it will be 3 squared plus 4, 9 plus 4 is 13. So now I could put in 5 and 13 as these bounds, and I'm already, these two integrals are definitely equal to each other. This one's all in terms of x, this one's all in terms of u. We know how to integrate this. We did it here, right? And we actually just got u to the 1/2 because the 1/2's canceled out. So this is the integral from 5 to 13 of u to the 1/2. And these are already in terms of u. So I don't need to ever think about x's ever again. What do I do to evaluate something that looks like this? I just do f of b minus f of a. I plug in the b minus plug in the a. So this is 13 to the 1/2, or like square root of 13 minus square root of 5. And now we're done. And this is like very short and nice because we didn't have to do all the intermediate steps of plugging the x's back in and then plugging the bounds in, blah, blah, blah. We just change it into u's and then our lives were easy. Now, either method, either you find your antiderivative and you put your x's back in and then you evaluate. That is always correct to do. Or you can use this method if you feel that it saves you some time and energy without having to like change the x's and whatnot. So it's kind of like a shortcut that sometimes is very nice because of how messy the integrals might be that you're working on. But it's your prerogative which one you use. I just wanted to share this though because I know some of the people who teach Calc 2, if they're doing a U-sub, they might do this and it's a nice refresher. Okay. Any questions at all about this particular problem? Would you guys like to practice using this method with a problem or two? So one problem that you guys could try this with, which ends up being very silly, but you can try it with, is problem number 10 on that sheet. Or why don't you try this problem? So here's a new one to try. I'll be back in a minute, you guys, so you can keep working, you can talk to a neighbor, we can talk about this when I return or whenever you guys want. is so totally right. Yeah. Yeah, so was the reason that you were like in was because plugging in makes sense, but actually like totally what numbers these are? Yeah, and I think like this kind of particular, the method is so nice, like when you plug, right, because you plug in a 1 and you plug in a 0, you're like, that actually didn't change the bounds at all. So that one is kind of like this anomalous one where the bounds didn't change. This one, like maybe you can kind of notice that if you did plug them in, you would get those and then you would take the difference. The thing is, so what you have written is 100% correct. You can also, E and the 1 are two like very special points on natural law. Plugins actually are really nice.
Yeah, that's what I went to that video.
Yeah, where you're like, I'm not sure what that is. Well, maybe I'll remind because I think probably a lot of us have this exact same question. But yeah, those are great. Do we want to talk about these as a group, or I can also just, if you are still working on some of the other integrals, I can come around individually. What are we doing?
As a group.
Let's talk. Thanks, Andrew. Okay, so for this problem, how did we get started on it? Like first, did we even think? So I was like, try this alternative method. Did we see how this is a good U substitution problem? We're like, if I mean, I guess I was kind of telling you, like, try this method for U sub. So what did you feel your U might be? Natural log of x. Good. So you picked natural log of x, and why did you pick natural log of x?
When you get the derivative of that, it's going to be 1 over x.
Okay, so du of this is 1 over x dx, because we know the derivative of natural log is 1 over x, and we see that living here. So that seems like a nice way to go. So if we're trying to rewrite that integral, in terms of u, what do we end up with?
You go u to the power of 6 over just
Well, it was over this x, but you pointed out that this is really dx. We've got this over x. This is the same thing as multiplying by 1 over x. Do we see this? So the 1 over x dx really just turns into a du, and then this is all we have in the integral. Okay. Questions about this part? Are we okay? All right, so then if our x is from 1 to e, so we have like x is 1, what is that going to change into in terms of u? And maybe even like unsimplified. If x is 1, u should be what?
Well,
what-
1, so.
What do we do with this one? So before we simplify even, like I take this one and where do I plug it into?
The x.
Into the x from the u equals natural log of x. So just like without trying to think too hard, if x is 1, u is what? Natural log of 1. And if x is e, what's u? Natural log of e. Great. Okay. Now it turns out this is fine. These are numbers. They look like, you know, kind of ugly numbers, but they're just numbers. So this would be totally fine, and you could just put these in here and integrate and be done. if you were wondering, like, I don't know, do I know what natural log of 1 is or what natural log of e is? So natural log, we don't know a lot of values off the top of our head. Natural log of 5, natural log of 12, I don't know what any of those are.